Hi guys, today we're going to be working with ellipses, and this is kind of like an elongated circle. So we've got two different formulas here for ellipses. Notice that you still see your, if I cover that up, your x minus h squared plus y minus k squared, just kind of like a circle, but this time we don't have an r squared. We have this a squared and b squared under the x and the y. So let's just talk about this for a minute. This a value, this is always going to be bigger than the b. And so depending on which letter it's under is going to determine whether the ellipse is horizontal or vertical as far as, how long it is. So if a is bigger, or I'm telling you, a is bigger, so a is always going to be bigger than b. Since it's under the x, it's going to be longer in that direction. Remember, a is always bigger than b, so the bigger number is under y, so this time my ellipse is going to be long that way. So the center is still going to be at hk, and it's still the opposite of the values that you see in the formula. We're going to talk about major axis. So the longer axis is what we call the major axis, and then the shorter one is what we're going to call the minor axis. So the major axis is parallel to the x-axis when the bigger number, a, is under the x. You might want to write that down. So you may want to write that, when the bigger number, a, is under the x. And again, the major axis is going to be parallel to the y-axis, and again, you might want to write that, when the bigger number, a, is under the y. And that's what gives us a either horizontal or a vertical ellipse. All right. Next part, it's kind of like just a definition of what this is. This is pretty wordy sounding, and I'm going to show you a picture that hopefully will help a little bit. But an ellipse is a set of all points, we're going to call those points P, such that the sum of the distances between them and two fixed points, called the foci, is a constant. Okay, that is very wordy. Let me show you a picture that kind of shows this. The 2 points, the pins that you guys see in that picture, those would be the foci. And notice how it's kind of making a right triangle shape there, right here. It's kind of making a right triangle shape here. We're going to call that our A and our B, and it's going to help us find where our C's should go. So it kind of looks like it's going to form like a right triangle here, and it kind of looks like Pythagorean theorem. Again, it's all just kind of ofs here. Let's go back to our problems here. Our constant we're going to call the letter C. So when we look for the foci, we're going to use the variable C, and it's going to equal a squared minus b squared. So, sorry, C squared is going to equal a squared minus b squared when we're doing this, when we're looking for our foci. All right, the vertex. The vertex, I'm going to show you where it is on this little diagram here. It's right there and right there. So the vertex is we're going to find it, the distance A from the center. So here's the center. This distance right there is A. That kind of looks like an A a little bit. So that's our A. That's how we would find it. From the center to the point on the major axis. Remember, the major axis is the longer axis. The co-vertex would be this point right there, and that's going to be the distance, I spelled distance wrong there, the distance B from the center to the point on the minor axis. Remember, the minor axis is the shorter axis. So you would take the square root of A to find this, you would take the square root of B to find this from our formula. The focus, that was those pins that I showed you in that last picture, is the distance C from the center to that point, and that's going to be on the major axis. So the focus, and when there's two of them, it's called foci, are going to be like these little X's right there. In this picture, the foci would be there.